All right, Maclaurin series. We're gonna look at an example of this just to understand how it goes. Let me put the example on the board first. In fact, I'm gonna put the general kind of formula on the board first. Okay. So essentially, the nth degree Maclaurin polynomial approximation to f. What is that? So for instance, so it's basically a sum of multiple derivations of the function. Okay. So the first term would basically be the function itself with no derivations at x equals 0 times x to the power of, well, 0 divided by 0 factorial. Because see, k is 0 in the first term, right? So this will be 0, this will be 0, and this will be 0. The next term would be the first derivative of the function at x equals 0. Because you see, it's always at x equals 0. No matter, what the function is, how many terms you're finding, this is always 0. Times x to the power of 1, because k is 1 now, because that's why you derived once also, divided by 1 factorial, plus second derivative at x equals 0 times x to the power of 2 over 2 factorial, and you keep going like this. The 10th term, for example, would be the 10th derivative. So the way we write the 10th derivative is, because it's annoying to write 10 lines like this, we just say bracket 10 bracket. This means the 10th derivative. So you derive the function 10 times. X to the power of 10 over 10 factorial. And of course, the nth term would therefore be the nth derivative x to the power of n over n factorial. A small mistake, I should have specified again that we are doing this at x equals 0 again and again. So we're inputting 0 into the function. Okay. So by using this, let's begin with a simple example. Following so far, by the way? I mean, I think you
Yeah,
already know the
yeah.
function, right? Yeah.
No, yeah,
Okay, so here's your function, and you want to write M4, which means you want to write down the first four terms of your series. In fact, that's wrong. When they say M4, they mean the first four terms, right? So you're gonna have one, two, three, and then four. So you're gonna go up to three, not four, because if you go up to four, you will have five terms, because the first term starts at 0, right? But regardless, M4 means write down the first four terms of the expansion for this. If they want four terms, they need four derivatives. Okay, so the first derivative would be no derivative at all. It would just be the function itself. The second derivative, I guess, would be the very first derivative, which would be, you need to derive this guy basically. Okay, so how do we
yeah.
derive him? There's a bunch of ways. I think I'm going to use basic power rule. 1 over 2 plus x basically just means 2 plus x to the power of minus 1, right?
Yeah.
So if you derive this, what do you get?
Mm,
So multiply by the power first.
it's like -1 and the thing inside,
Keep the inside
like
the
oh yeah,
same. Change
and
the
then
power.
times 1,
No,
and
no,
then like -2 to the power of -2
exactly. And
times
then
1.
times the derivative of the inside, which is 1, which is basically just this. That's the first derivative. So
Yeah.
you got the 0th term, you got the first term, you need the second term now, which will be another derivative of what we just got. So can you derive this now?
This is gonna be 2, 2 to x plus x minus 3, like
And
the
then
power
times
plus
1,
3
but no
times
point.
1. Yeah.
Yeah. And finally, the third term, we will have four terms when we finish this. The third term would have another derivative of this guy, which is,
-6
yeah,
-6 2 plus x -4.
exactly. So now that you have the derivatives, we know this, we know this, we know this. Well, we don't know these yet because we need to plug in 0 into all of them. So plug in 0 into all of these guys now. So let's just do it. We have f of 0, which would be 2 to the power of minus 1. We have f prime of 0, which would be minus 1 times 2 to the power of minus 2. So that would 1 over 4 basically, because 2 to the power of minus 2 would just be 1 over 4.
Mm-hmm.
The second derivative at x equals 0 would be 2 times 1 over 8. So 1 over 4 again, because 2 over 8 is 1 over 4. And finally, the third derivative at x equals 0 is going to be minus 6 over 2 to the power of 4, which is minus 6 over 16, which is, if you divide both the top and the bottom by 2, you will get minus 3 over 4. So now you know all three, well, basically just these guys. Okay,
Mm-hmm.
so far so good.
Yeah.
Very involved calculation. So 1 over 2 times x to the power of 0, which is, by the way, just 1, so we don't need to write this, divided by 0 factorial, which is also just 1, plus the first derivative, which is negative 1 over 4, times x over 1. Then plus the second derivative, which is also 1 over 4, times x squared over 2 factorial, plus the third derivative, which is minus 3 over 4, times x cubed over 3 factorial. This is what we have, right? Let's clean it
Yeah.
up. We have 1 over 2 minus 1 over 4x plus 1 over 8x squared minus 1 over 4. Oh no, because 3 factorial is 6, because 3 times 2 times 1. So we have minus 3 over 24x cubed. This is an approximation of my function. Now, what's the point? Why, like, the first time I learned this, I was like, why on earth did I just do this? What was the point, right? The point is that this series, these four terms, are much simpler for a computer to calculate than that function as a whole. Okay.
Oh.
Uh, and so that's basically the reason we use these. The applications become more intense as you grow to like more complex functions later down the line in engineering. Because engineering math is, the functions aren't as simple as this one. Functions become much worse and much, much more involved, like, fifth powers, 16th powers, etc. At that point, calculators even have trouble making the calculation. So what we do is we make an approximation of what the function's values will be. Now, the B part is a perfect example of why. Look, we found M4, right? In fact, we should
Mm.
call this not an approximation, we should say M4 of x, which is an approximation of the function itself. M4 is exactly this, which is an approximation of what the function is. Okay, now let's learn about why we just did this. Watch this. If I find out what happens if I plug in x equals 1 into my approximation, into my Maclaurin series, I will get 1 over 2 minus 1 over 4 plus 1 over 8 minus 1 over 8, I think. Yeah,
Yeah.
8. If you clean this up, you will realize that the answer is very easy to calculate. 1 over 2 minus 1 over 4 is just 1 over 4. Now, the Maclaurin series says that when x is 1 in my function, it should be roughly equal to 1 over 4. Let's see what my function's actual value is when x is 1. If I plug in 1 into my main function itself, I will get 1 over 3. As you can see, this is horrible. But you can imagine that the more terms I add into my Maclaurin series,
The closer it
yeah,
will get.
exactly. The closer it becomes to the actual function's behavior. Okay, that's the idea of the Maclaurin series. All right, so here's the next question. I think this is from a past paper, right?
I got it from Revision Village.
Okay, okay. Probably past paper then. So
Probably,
you have
yeah.
a function given to you, and it says that by finding a suitable number of derivatives, determine the first non-zero term in the Maclaurin series. Now, before I talk about, what this question even means, see, when you expand the Maclaurin series, there's a little bit of an issue, and that is that every term has, like, in the function, in the derivatives, everything, you have to plug 0 into x, right?
Mm-hmm.
Which means that if your function is 0 at x equals 0, you're going to keep getting 0 terms, right? Look at what I mean. If I plug in 0 into this function, watch what happens. E to the power of minus 0 is just 1. Sine of 0 is 0. X being 0 would just be 0. 0 squared is just 0. See, the whole first term of the Maclaurin series is ignorable. You don't even need to find it. It's 0. See what I mean?
Mm-hmm.
Same, right? So now, if I find the derivative of my function, meaning I'm now talking about the second term in the Maclaurin series. As you can see, in the Maclaurin series, the second term contains the first derivative. So if I find the first derivative of my function, I will need to do a bit of work here because this is a product rule problem. You have two things multiplying together. Let's call the
Mm-hmm.
first guy U and the second guy V. Okay.
Yeah.
So U prime. What is U prime here?
Mm, minus e minus x.
Okay. And V is just sine x plus. What is V prime?
Cos x or no, just cos x.
No, just cosine x. And then U is the same. Okay. That's the derivative of just the first term. What's the derivative of minus x? This guy?
1.
Minus 1. What is the derivative of x squared?
2x.
Exactly. Now, this is my first derivative. If I plug in 0 over here, watch what happens. This is 1. Oh no,
Mm-hmm.
minus 1, sorry.
Minus 1,
Yeah.
yeah.
Sine of 0 is 0.
0
Cosine of
plus,
0 is 1, right?
what is, yeah,
And this is,
1, 1.
what is this? And then plus 0. So
So it's
this
also 0.
looks like things were going well, but this guy gets cancelled out and it ends up being 0 again. Wouldn't, if this wasn't 0, then I would be surprised this is a 7-point question because they want us to find now the second derivative of this guy, which is going to be another pain for us. So let's try to derive this again.
So it's just e minus x.
E minus x, carefully now,
Uh,
times.
then minus cos x.
No, no, no. So you
Not just
derive the
cos.
first, yeah. No, no, you derive the first guy, so you have to keep the second guy the same because
No,
u
okay.
prime and then v plus now,
Oh, yeah, 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 yeah,
yeah.
yeah. Okay.
That's why I said be careful. Bit of a long one. So now keep the first guy the same and multiply by the derivative of the second guy.
Which is cos x.
Negative cos, unfortunately. So sine
Uh,
is cos, no, sorry. Oh, no, I'm sorry. Never mind. Sine is cos. My bad. Cos is negative sine. I
mhm.
confused myself. So again, sine derives to cosine. Cosine will derive to negative sine. Okay,
Yeah,
now,
and then plus minus sine x.
okay.
Uh, and then like
Yeah,
normal
you don't touch it. Yeah, plus.
plus cos x
Yeah,
and minus e minus x
good. Minus 1
and plus 2.
plus 2. Exactly. Hopefully this works. So if I now
Yeah,
plug in
hopefully.
0, because then we'll have 4 product rules to work with otherwise. So if I plug in 0 here, I have, well, this is just 0 because, this guy is
Hmm.
0. This guy is also 0, so cancel him, cancel him. I
This
was
is
getting worried.
minus 1 times 1.
Yeah,
So just minus 1, yeah.
exactly. And then
Plus,
here, same thing.
yeah,
Minus 1 again. Oh
plus
God.
2. That's why
Okay.
it's 7 marks, I think.
Yeah. So you had 0 again. So yeah. Okay, that's
So like now
unfortunate.
we take a rope.
Yeah, exactly. PG 18 though. So the good thing only that I see here is this. Wait, let me show you the good thing that I notice in this situation now. So instead of going from scratch again, realize that you already know what the derivative of this guy is. It's this. So you know the derivative of this guy, and you know the derivative of negative this guy already. You see what I mean?
Yeah.
So I can just kind of write this a bit quicker because I already know that e to the power of minus x sine x, meaning this, oh no, meaning this, will derive to this whole thing. Okay? So that's the only way you can make this question a
So it's like
little bit
0. So
faster.
it's like 0.
Ooh, that's actually a good point. So this is the derivative of this is directly going to be 0. You're right. And the derivative of this is also directly going to be 0. Oh no, but this is negative. Oh, wait a second. Wait a second. I just realized we don't need to do all this. Look, if I just simplify this, I will notice this guy cancels out with this guy entirely without doing anything. They're negatives of each other.
Can we
See?
do that though?
Yeah, of course. You have e minus x sine x and you have minus e minus x sine x. They cancel out.
Ah, okay.
Yeah, we should have done that earlier anyway, because that's exactly what's happened here. And these guys can be added up because you have the same thing twice. So you have
Hmm.
minus 2e minus x cosine x, and then you have plus 2. So that's, it's not as difficult as it looked originally. it's easy to fall in the flow and kind of do extra work. But this could have been simplified into something much well, we just did. It's now much easier to derive this because you just have one thing to work with. So let's do it. Keep the -2 outside, or in fact, okay, do it your way. What do you think the derivative is going to be?
Uh, like two e minus x.
And then
Uh, just times cos.
exactly, because you did not derive the second one because you've already derived the first one.
Mm-hmm.
Plus,
Like plus minus sin x. Okay,
yeah,
yeah.
exactly. Good.
Minus sin x, and
And
then
then the
nothing.
exactly. So now we can plug in 0 into this and hope to God that something good comes up. This is going to be 2, and this is going to
Mm.
be plus 0 because sine of x will become 0. So the answer is 2. So the fourth term, the first term was 0, the second term was 0, and the third term was 0, and the fourth term is where finally we had a non-zero coefficient. So now they said find a suitable determine the first non-zero term. So what is the fourth term going to look like? It's going to look like this, right? So that is 2 times x cubed over 6, which is x cubed over 3. That is your final answer.
Opa.
Yeah. So
There
bit
you
of a
go.
mess, honestly. Um, but I don't know, just a very not a very fun question. Not a fun question at all. But I guess, I mean, once you realize this little thing, it's your saving grace, because then it's really super easy. Yeah. So, any questions?
No, no. I
Perfect.
actually it was kind of pleasant.
Yeah. Okay, so we have a function given, and we need to use successive differentiation to find the first 5 non-zero terms in the Maclaurin series. So let's start, and probably won't find all 5 because it's going to take years,
Mm.
but let's start with it. So the first term is, oops. The first term is just going to be plugging 0 into this and getting the answer. Let's see what happens. If I plug in 0 directly, I get this. And unfortunately, natural log of 1 is 0, which means the very first term is 0, so that doesn't count. That's very good news. So by the way, again, just to remind you, natural log of 1 is 0. That's why. That's the problem, basically. So
Mm-hmm.
now we can now try to derive this. And to derive this, I'm thinking, okay, so we have u and we have v, right? 2 minus 2x is u and natural log of 1 minus x is v. So u prime is just going to be -2 and v is just 1 minus x plus u stays the same this time and v prime. Just to tell you the general form, the natural log of a function will always derive to 1 over that function times the derivative of the function. Okay?
Yeah. Okay.
So natural log of 1 minus x will become 1 over 1 minus x times, times the derivative of 1 minus x, which is -1. So that's why I have a minus up here. Okay, is this clear?
Yes.
And then plus 2, of course, because the 2x needs to be part of this. And then if I plug in 0 into this guy, I will get, remember, natural log of 1 is 0, so this is just going to be 0. And, oh, this is fun. Okay, we have just this whole first term goes to 0. Over here, I'm going to have 2. So -2 over 1, 1, and then plus 2, which is also perfectly 0. So the second term doesn't count either because we want the first non-zero terms. This is a very nice question. So you see the point, I hope. I'm going to do one more term. But okay, so actually, there is something I want to tell you very important in this point. So it's very tempting to be frustrated and kind of keep moving in this direction. But before you find the next derivative, look at your previous one and kind of think about simplifying anything you can possibly simplify, okay? Because you see, over here you have 2 minus 2x. If you take the 2 out, right, and you have a minus here, so let's put the minus here. If you take that 2 out, factor it out, you can actually make a very, very useful factorization here, which would have told you early on that, you see, your first derivative is just this. It's not all of that, it's just this. So simplification is key. So whenever you have this question where they're like, oh, first five, like first billion non-zero terms, do not get scared because they've designed it in a way that once you get your first derivative and you simplify it, your second derivative is going to be super easy to find. So simplification is key, okay?
Mm-hmm.
So this question is actually very easy now because after the simplification, all I gotta do is derive this guy, which is very easy to derive. Ignore the -2 for a second, it's just a factor. The natural log of 1 over 1 minus x, sorry, will just derive to 1 over 1 minus x times the derivative of 1 minus x, which is -1, which gives me 2 over 1 minus x. Much easier to find, right? Could you follow?
Kind of.
Okay, so natural log of 1 minus x, right? When you derive it, again, 1 over the function first, so 1 over the function times the derivative of that inside function. The derivative of 1 minus x is just -1. So the derivative of natural log of 1 minus x without the -2 is just going to be -1 over 1 minus x. But since you have a -2 here, you multiply that with the -1 and you get 2. Okay. Did you have any trouble understanding this, by the way?
No, 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 no.
Okay, good. So now that's your second derivative. You plug in 0 here and you get 2 because 2 over 1 minus 0 is just going to be 2. Perfect. That's our first non-zero term. Nice. To find our second non-zero term, derive that thing again. So this is just 2 times 1 minus x to the power of -1. The reason I did that is because it makes the power rule easier to kind of observe. So what's the derivative of this going to be? What do you think?
Um, minus 2, 1 minus x, and then times -1.
No, what's the power going to be though?
-2.
Exactly. Times -1, which makes it 2 over 1 minus x whole squared, which is in fact also 2, isn't it? Because, oh sorry,
I've
when you
zero
plug
then.
in, yeah, when you plug in 0, it's 2. That's what I meant. Okay, nice. Maybe this is what they were trying to show us. Let's see. Let's do it one more time. So again, this is 2 times 1 minus x to the power of -2. Oh, it's always going to be 2, isn't it? Because now, no, never mind. I'm wrong. So you're going to get -4 times 1 minus x to the power of -3 times -1, which is 4 times 1 minus x to the power of -3.
Mm-hmm.
When you plug in 0 into this, you're going to get 4. Okay, interesting. We're starting to see an interesting pattern. 2, sorry, 2, 2, and then 4. Let's see. What's the
Is it
next
gonna
one
be
going to
4
be?
this time?
Let's see. I think it's going to be 6. No, it's
Probably.
going to be 12 because like 3 times 4 now, right? So we can
Okay.
already kind of foresee this. It's going to be 12, isn't it? Because when you derive this, you're going to do 3 times 4. That's what's going to be here. And there's going to be a -1 to cancel out that -1, blah, 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 which gives you a 12. And if you do the sixth one, you will get, so this, okay, let me just write it down.
It's gonna be like 48, no?
I believe so, yes. But the fifth derivative would have been 12, 1 minus x to the power of -4. The sixth derivative is going to be 48, 1 minus x to the power of -5, and so on. And this is 12 when you plug in x equals 0. And when you plug in x equals 0, it's going to be 48. So this is your first term. No, first, second, third, fourth, and fifth. So once you catch the pattern, it's over. However, deduce that for n is more than or equal to 2, the coefficient of the x to the power of n will always be 2 over n times n minus 1. I do not know how that is possible, but let's see. So now that we know the powers, now that we know the derivative values, okay, so which term is this going to be part of, right? What do I mean? Like, what's the power of x going to be with the second derivative? X squared, right?
Mm-hmm.
What's the power of x going to be with the third derivative? X cubed. And then you have 4x to the power of 4 over 4 factorial. plus 12x to the power of 5 over 5 factorial, and then plus 48x to the power of 6 over 6 factorial. This is what you have, right?
Yeah.
Okie dokie. So, okay. When n is more than or equal to 2, the coefficient is always 2 over n times n minus 1. How? Let's see.
They are
So,
tweaking. I
yeah,
think they, I think
this
they are
is
just
2
tweaking.
over 2 times 2 minus 1. This is 2 over 3 times 3 minus 1 times 3 minus 2. This is 4 over 4 minus 1 times 4 minus, oh no, 4 times 4 minus 1. I'm just going to write it like this. 4 times 3 times 2 times 1. This is 12 over 5 times 4 times 3 times 2 times 1. And this is 48 over 6 times 5 times 4 times 3 times 2 times 1. Okay, so we have 2 times 1 and 3 times 2 times 1. All I've done is I've written down the factorials like this because I want to say that I want to see that they're basically saying that it's always the same as 2 over n times n minus 1. Now, what do I mean? What is n here? N is 2. The power of x basically is n. N is 3 here. N is 4 here. N is 5 here. And n is 6 here. Let's see. Here, I can cancel out this 2 with this 4. It gives me 2 here. Over here, 3 times 2 is 6, right? So 6 and 12 can cancel out, give me a 2 here. And over
Mm-hmm.
here, 4 times 3 times 2 is 24. 24 times 2 is 48. Watch this. 2 over 2 times 1. 2 over 3 times 2. 2 over 4 times 3. 2 over 5 times 4. 2 over 6 times 5. As they said. Every single time, it is 2 over the power of n times the 1 minus, sorry, the power of n minus 1. Is exactly as they expected. So honestly, the tough part was finding these. You will get about 6 points. Oh no, actually you will get all 8 points for doing
No,
that.
again,
Yeah.
can you
Ah,
show me that part again,
okay.
actually?
Do you agree with this?
Yeah. This I
Okay.
understand.
These are just numbers I've put in. Which numbers? I've put in these powers, sorry, these derivatives. And
Yeah.
why did I put these powers of x? Because look, this is the second derivative, so I put x squared. Third derivative, I put x cubed, and so on. That's just how the Maclaurin series works, like this. First derivative has x1, second derivative x2, 10th derivative has x10, and so on. And by the way, the bottom is the same as the power of x. So 1 factorial, see, 2 factorial, 10 factorial.
No, this I
Ah,
understand.
you get it. Okay.
I just don't get how did you put
Okay.
like
So
yeah, that part.
they are claiming that if the power of x is n, then the coefficient of x attached to it is 2 over n times n minus 1. They're claiming that this is true. Let's see. So what are they claiming? They're saying that, for example, if the power of x is 2, it should be 2 over 2 times 2 minus 1, so 1. You see? And if it's like, for example, 5, it should be 2 over, because the top is always 2, 2 over 5 times 4, right? If it's the sixth term, it should be 2 over 6 times 5, and so on. That's what they're claiming.
Okay,
And when I write down
okay.
these factorials and I expand them, and I cancel out the necessary stuff to make a 2 appear at the top, I end up with exactly as they expected. See, for the third power, it's 3 times 2. Fourth power is 4 times 3. Fifth power is 5 times 4. But only after I canceled out just enough for a 2 to appear at the top. I could still cancel out the 2 and get a 2 here, but that wouldn't make me see what they're trying to make me see. You see what I mean?
Yeah.
Yeah. A bit of a tricky one, honestly, the last part, but a good question nonetheless. I think but the lesson, the very big lesson that needs to be learned from this question is when you have a question that has suspiciously too many terms to find, remember that they're not testing your ability to do a lot of math. They're testing your ability to do math smartly. When you find your first derivative, you
Well,
will,
knowing IB, everything's possible.
yeah. So when you find your first derivative, you gotta make sure you simplify it as much as humanly possible so that when you find the second derivative or the third derivative and so on, it's much easier because you won't have these excessive terms to find. See here, the 1 minus x is canceled out and gave you a much simpler looking first derivative, which is easier to derive. Okay?
Yeah.
So simplification and canceling stuff out is the key to solving the questions that are big points and you're supposed to find a lot of terms. Okay.
Yeah, yeah, I see.
Any questions about this?
No, actually,
Damn,
no.
I'm exhausted. All right. All right, here we go. So here's the next question. First non-zero, three non-zero terms of this Maclaurin series. Okay. This is going to be a product rule problem with a trigonometric and a natural log bane of people's existence, I guess. But so what's the derivative of, so let's find the first term, right? The first term is just going to be 0 plugged into this, which will be natural log of 1 plus 0 times sine of 0, which is of course 0. So it doesn't count because they wanted non-zero terms. Now we need to find the first derivative then. So what is u prime? What do you think? Because we're doing u prime v plus v prime u, right? So we're gonna try to find the.
No, no clue. No clue.
Okay. So for natural logs, where are you? Here. Always 1 over the function. Do nothing
One
to
over
it.
the
Just 1 over the
function.
function times the derivative of the function itself. That's it. The natural log leaves. It never, like, it doesn't come back.
Oh,
Just
I was looking
uh-huh.
at the things above.
Ah. So 1 over the function, what is that going to be?
So like 1/1 plus 3x
Exactly. And then multiplied by the derivative of that function again.
multiplied by
3.
3.
Hmm.
3, yeah, just
Good.
3.
So this is u prime, sorry, u prime. And then times v plus v prime, which is easier to find, which is, so this is v
This is cos.
cos x, exactly. And the natural log stays the same for now. Okay. So we basically have 3 over 1 plus 3x times sine x plus cosine x natural log of 1 plus 3x. So this is your first derivative, and we can plug in 0 into this now and get 3 over 1 times 0. So this is all just 0 when you plug in 0 because sine of 0 is 0. And over here, you're going to have 1 times natural log of 1, which is also going to be very nicely 0. So this term does not count either. That's fun. Okay. Second derivative.
Oh
Okay.
yeah.
uh, These questions are not designed to be done like multiple parts of these done in the same day, I think. But anyways, so I'm gonna rewrite the first derivative in a way that it's easier to find the derivative. This. So I just converted the 1 over the plus, sorry, 1 over 1 plus 3x
I mean
into 1
it's
plus.
3 points. I mean
It-
it's 3 points. Wait.
wow. Okay. Hopefully the code is gonna be cracked in this part then.
Oh,
Maybe.
because
Yeah.
it's calculator question.
No, but you can't find the derivative using a
Yeah,
calculator.
yeah, true.
So let's try to derive this. So what's the
Imagine.
derivative of this gonna be? Let's do
Um
u prime first. So this
my
can be u.
minus okay. Minus 3 1 plus 3x to the power of -2
Then
sine
time,
x.
no, times 3 also because you gotta derive the inside.
Oh, true, true,
Yeah,
true.
sine x.
Okay, okay.
Yeah. Then
Uh
plus
yeah, plus just like 1 plus 3x minus 1 times cos. Yeah.
finally we have this guy. So u prime, what is that?
We actually use it. Oh yeah, yeah, it's fine. Okay.
Yeah.
Um plus minus sin
Times
ln
that.
ln 1 plus 3x plus cos x 1 over 1 plus 3x times 3. No, yeah, yeah, times 3.
Now we have this. Let's see if we can do any simplifications here first.
Looks
We
terrifying.
can add these two because they're the same term.
Okay, how can I use calculator in that exercise respectfully?
In this in this part, absolutely impossible.
Okay, nice.
Yeah, nothing you can do. So you are absolutely stuck with using your brain. whatever is left of it by the time this question pops up.
Yeah, yeah, by the time, yeah, exactly.
Yeah. So you have 6 plus 1 plus 6 over 1 plus 3x times cosine x. And then finally you have this. By the way, the reason that became 6 is because you have two terms that are the exact same with a 3 at the top, a 1 plus 3x at the bottom, and a cosine x attached. So I added them together. Okay?
Yeah.
Making sense? And then you plug in 0 into this, which gives you minus 9 times 0. So this is all just going to be 0 because sine x is 0. This is going to be 6 over 1 times 1, so just 6. And this is all going to be just 0. So thank goodness we have a non-zero term coming up. Perfect. Now, to find the next term, okay, I'm not going to do it because I'm exhausted. No, I'm kidding. So you can try it on your own, but it's very easy because look, if you look back, you will realize that you already know how to derive this. You already found it. It's basically this stuff.
Mm-hmm.
The derivative of this guy is given. We've already found it. What else do we already know? Nothing else. We know absolutely nothing else. So the rest of it,
Very
you kind of
nice.
just have to derive this and this on your own using product rule. But again, use the fact that you can rewrite this guy as minus 9 1 plus 3x to the power of negative 2 sine x. And you can write this guy as 6 times 1 plus 3x to the power of minus 1 cosine x. And then use product rule. You will only need to do this 2 more times and you will be done. Okay.
Okay.
And
Yeah,
that is
but
the end of this question, basically.